So welcome back. Let's look at operations with real numbers. So real numbers, we say that they can be represented as capital letter R this way. So let's say for all elements A, B, C to be element of real numbers, right? Then we have that A plus B and A multiplying B belong to R, right? So on the general form, we are going to be taking A to be equal to 2, we're going to be taking B to be equal to -3, and we're going to be taking C to be equal to 4, right? So we are going to be using this for the rest of this to show that this is correct, right? So what the first law here is saying is that if we do A plus B, right, the answer is going to be element of R. So let's check that out. So A is 2, then this plus -3, which is going to be equal to what? -1. And -1 is actually a real number, right? So, and if we have A multiplying 2 and A multiplying B, so what this is saying that A multiplying B should be an element of real number. So let's check it. It should be 2 multiplying -3, which is equal to -6. And indeed -6 is an element of real number. So that means this law stands, number 1. So let's look at number 2. Number 2 is talking about commutative law of addition. Now, when we speak of commutative law, we say that means that A plus B is equal to B plus A. This should be A here. A plus B is equal to B plus A. So it doesn't matter whether you are adding A to B or you are adding B to A, right? It's going to give you the same thing. So let's check this out and see. Let's do A plus B. A plus B, we had it to be -1, right? We had A plus B to be -1. So let's do B plus A. So B plus A is going to be, B plus 8 is going to be -3 plus 2, which is equal to what? -1, right? So this is also equal to -1. So which means this stands. A plus B is -1, B plus A is also -1. So that is correct. So let's look at number 3. Number 3 is associative law of addition. Associative law of addition. Let's check it out. Associative law of addition, what does it say? Associative law of addition is saying that if we have A plus into bracket of B plus C is going to be equal to bracket of A plus B plus C. So let's check for the left hand side, right? We have our value of A to be what? We are checking for left hand side now. Our value of A is 2. This plus into bracket of B is -3 plus C. C is 4. So this is 2 plus 1, which is equal to 3, because -3 plus 4 is 1. So 2 plus 1 is equal to 3, right? So this is the left hand side. So let's look at the right hand side. So let's consider the right hand side. So considering for the right hand side, we are going to have A plus B first. A plus B, which is 2 plus -3, right? And this is plus C. C is 4. So this is going to be what? 2 plus -3 is -1 plus 4, which is equal to 3. Alright, so we have 3, 3. Our left hand side is equal to 3 and our right hand side is equal to 3. So which means the commutative law, the associative law is correct. Associative law of addition. So let's also check for the commutative law of multiplication, where A multiplying B is the same thing as B multiplying A. So we already have A multiplying B to be -6, right? Look at it here. A multiplying B is equal to -6. So let's check for B. We have A multiplying B to be equal to B multiplying A. and we have a multiplying b to be equal to minus 6. This is the left hand side. So let's check for right hand side now, where we have b multiplying a. So b is minus 3 multiplying a, which is 2, is still equal to minus 6. So you see that the 2 are minus 6, so which means this also stands. The cumulative law of multiplication is correct, right? We are trying to validate all these laws so that you know the properties of our real numbers. It's going to help you further in other calculations as well. So the number 5 law is talking about associative law of multiplication. Remember, we've done that of addition already. So let's check that of multiplication and see, which means a, right, multiplying b multiplying c is equal to a multiplying b multiplying c. So let's check left hand side. For left hand side, we have a to be 2 multiplying b minus 3 multiplying c, which is 4. This is going to be equal to 2 multiplying minus 12, which is equal to minus 24. So let's check for the right hand side now and see, compare our answer. We have 2 multiplying minus 3 multiplying 4, which is going to be equal to, this is minus 6 multiplying 4, which is also minus 24. So we can see that the both values are the same. So which means this associative law of multiplication stands as well. So we have the next law, which is referred to as a distributive law. The distributive law is more of like sharing. It's more of like opening the brackets. So when you have something like this, right, this is going to be a multiplying b plus a multiplying c, a multiplying b plus a multiplying c, right? So that is what it means. So we could check these two. A is 2 multiplying b is minus 3 plus 4, right? So this is left hand side. So this is 2 into minus 1, 2 into plus 1 rather, minus 3 plus 4 is 1. So this is going to give you 2. This is for left hand side. So let's check the right hand side, where we have AB plus AC. Alright, so A is what? A is 2 multiplying B minus 3 plus A 2 multiplying 4, right? So we're going to have this to be minus 6 plus 8, which is equal to 2. So we have 2 here, we have 2 here. So this also stands. Right, that also stands. So the distributive law also stands because it's confirmed. So let's look at the 7th property, which is very interesting. This is called the identity property. Identity property, where if we have a plus 0 is equal to the same thing as saying 0 plus a, which is equal to a, right? Then you have 1 multiplying a is equal to a multiplying 1, which is equal to a again. So this is called 0 is referred to as the additive identity, and 1 is referred to as multiplicative identity, right? 0 is called the identity with respect to addition. That is what I refer to as additive identity. And the 1 is called identity with respect to multiplication, which is a multiplicative identity, right? So that is what identity is all about, right? So there's also something called inverse of a number. For instance, additive inverse of 1 is minus 1, right? Subtraction is the inverse of addition, and then if we have 2 now, the additive the multiplicative inverse of 2 is 2 raised to the power of minus 1, which is the same thing as 1 over 2. So why subtraction is the inverse of addition, division is the inverse of multiplication. Where subtraction is the inverse of addition, division is inverse of multiplication, right? So here now, if we have x to be equal to x plus a to be equal to 0, it means x is going to be equal to minus a, which I say this is additive inverse of a, right? If x is equal to a, the additive inverse of x is going to be minus a, right? So now if also you have ax to be equal to 1, then that means x is going to be equal to 1 over x, 1 over a rather. So this is the multiplicative inverse of x. So let's quickly look at some self-assessment here, right? We have some self-assessment here. So we have to identify the property used in the following, and this is 2 multiplying 13 plus 8 multiplying 13 equals to 2 plus 8 multiplying 13. So this is a distributive property, because you see that they are opening the bracket, they are distributing 13 here, right? They distributed 13 to 2 and then to 8, so it's a distributive property. So the number 2 is which property is reflected in the following. 7 times 5 is equal to 5 times 7, that is commutativity. Alright, so number 3 is which of the following statement is true. 7 divided by 0 is 7, 7 divided by 0 is 0, 7 divided by 0 is, this is the correct one. 0 divided by 7 is 0. This is the correct statement. Remember I told you that this is undefined, this is undefined, right? This is the correct one. So in our next video, we are going to be looking at something interesting. We are going to be dealing with absolute values.